Hello friend, today I am going to explain the third question of first chapter real numbers exercise 1.1. So question is use division algorithm to show that the square of any positive integer is of the form of 3p plus 1. First of all, we know that division lemma equation is by division lemma. A is equal to BQ plus R. The value of R must be 0 less than is equal to B or less than B. The value of R must be less than to value of B. So let assume that A be any positive integer. In the form of 3q plus 1 and 3q plus 2. Comparing this with the equation of division lemma equation, A is equal to BQ plus R. Comparing this equation with the above equation, we get value of B is equal to 3. If the value of B is equal to 3, then the value of R must be 0, 1 or 2, not 3, because already we said that the value of R must be less than 2 value of B. So value of B is equal to 3, then the value of R must be 0, 1, 2. So let's solve the next question. Case 1, R is equal to 0. We know that division lemma equation is A is equal to BQ plus R. The value of B is equal to 3, the value of R is equal to 0. A is equal to 3q plus 0. A is equal to 3q. In the question says that the square of any positive integer. So take squaring on both sides. Squaring on both sides. A square is equal to 3q square. A square is equal to 3 square q square. A square is equal to 3 into 3q square. A square is equal to, therefore 3q square is equal to p. Put in the place of 3q square we put p. So case 1 is done. Next we are going to solve the case 2. Case 2, R is equal to 1. The value of, we know that division lemma equation is A is equal to BQ plus R and value of B is equal to 3. The value of R and the value of B substitute in the above equation. A is equal to 3q plus 1. As the question is squaring, take squaring on both sides. Squaring on both sides. A square is equal to 3q plus 1 whole square. This question is in the form of A plus B whole square formula. We apply the A plus B whole square formula here. A plus B whole square is equal to A square plus 2AB plus B square. So this is A and this is B. A square as it is. Now here apply the formula, this formula. A square means 3q square plus 2 as it is. A mean 3q, B mean 1 plus B square mean 1 square. A square is equal to 3 square q square plus 2 into 3 6, 6 into 1 6, 6q plus 1 square. 1 square mean 1. 1 square is equal to 1. So A square is equal to 3 square, we can write it as 3 into 3q square plus 6, we can write it as 3 into 2q plus 1. A square is equal to 3 common, remainder is 3q square plus 3 common, remainder is 2q plus 1 as it is. Therefore 3q square plus 2q is equal to P. In the place of 3q square plus 2q we put P. So A square is equal to 3 into, in the place of 3q square plus 2q we can write P plus as it is 1. Second case is completed. Now we are going to solve the third case. Case 3, R is equal to 2. The division lemma equation we know that A is equal to PQ plus R. The value of R we know that 3. Substitute the value of R value and B value in above equation. A is equal to 3Q plus R. Taking square on both sides, squaring on both side. A square is equal to 3Q plus, the value of R. The value of R is 2. To squaring on both sides. Here we apply the formula of A plus B whole square formula. A plus B whole square is equal to A square plus 2AB plus B square. So this is A and this is B. A square as it is equal to, in the place of A in the place of A we write 3Q whole square plus 2 as it is. A replaced with 3Q, B replaced with 2 plus B replaced with 2 square. A square is equal to 3 square Q square plus 2 into 3 6, 2 into 3 6, 6 into 2 12, 12Q plus 2 square is equal to 4. A square is equal to 3 square, we can write it as 3 into 3Q square plus 12, we can write it as 3 into 4Q plus 4, we can write 3 plus 1. 4 we can write it as 3 plus 1 because 3 plus 1 is equal to 4. So A square as it is, 3 common, remainder is 3Q square plus 3 common, remainder is 3Q plus 3 common, remainder is 1 plus 1 as it is. Therefore 3Q square plus 4Q plus 1 is equal to P. a square is equal to, in the place of 3q square plus 4q plus q plus 1, in the place of 3q square plus 4q plus 1, we put p, 3 as it is plus 1 plus 1 as it is. Case 3 is also proved. Hence proved.